This second video, I'm going to be showing various ways or methods to verify convergence or divergence, and also showing how you can verify the conditions. And so, as shown in the last video, and all of these are going to include this, but because, as you can tell from this video, I'm not very good at drawing it, so I'm not going to draw it like 8, 10 times. One, and they all are in this. So for geometric series, label that G, it's A, R, N, and R greater than or equal to, or less than or equal to, greater than or equal to 0, less than or equal to 1, converges. But if R is greater than or equal to 1, it diverges because it would just keep increasing instead of focusing on one point, which is what divergent means. And then for P series, same kind of thing, where you're looking at a certain variable or a number, which would be in the case if it was a legit problem instead of just the set conditions for it, for 1 over NP. And then the P, if greater than 1, converges. This is what you'll see with a lot of them, where it'll be greater than the one it converges and less than one diverges. And I think that's for most of them, except for a few. And if P is less than 1, it diverges. And another test we can talk about are the integral test, where instead of AN, you're getting F parentheses N. And then if you are to take the integral from 1 to infinity of F, or for my terrible drawing, I'm drawing about as good as my handwriting. Um, and then if this is equal to a finite number, which is represented as L in our notes. So if it's L, it's convergent. And then if it's like D and E, or say it just goes to positive or negative infinity, looks like 8. It's infinity. Really bad at drawing on MacBook. Um, this would diverge. And then what you can also do, actually, I'll just use the space over here. Um, and then what else you're looking for is when you're verifying the conditions of this, what you can do. Well, here, I forgot the last test. The ratio test, which here, go back to drawing. Use this now for the ratio test. Ratio test is when you're going to get the limit of it from n to infinity. And then you're going to have an absolute value of a over n plus 1 over a over. And then this ratio, if it is less than 1, you're going to converge greater than 1, diverge. This is what I was talking about earlier, how you can see here. If it's greater than p, it converges. And then for the ratio test, it kind of switches. So for P series, you can think of it as like the normal one, and then ratio you can kind of I remember it as reverse, and then that's how you know the reverse converges and diverges reverses. So reverse ratio is kind of how I remember it. It helps me remember it. It's also reverse for the root test, and the root test is just limit and infinity, but it's square root a n to the power of n, and whatever that limit goes to, if it's less than converges. So both the R's are reversed compared to the P series, which is a good way to remember it. Helps me. Greater than averages. But if it's equal to, same thing with this one. This is where you're going to start seeing the inconclusive, which means you're not really sure whether it's convergent or divergent, because if it's equal to one, it's not really giving you enough information for that. And then I for inconclusive. And then verifying these conditions. You can verify these. I'm going to go to the chart I have in my learning journal. You can verify these by using these tests. And then what you can also do, if it looks similar to a series in your toolbox, you can just use direct comparison, or you can also use limit comparison, which kind of shows if there's AN and BN, or like if it's a big one where it's AN and BN, you can only have to test one of them and you can find out what the other one is, which can be very helpful. Confirming this, verifying the conditions, you can also go through graphs, showing how to graph it. Look, you can do multiple values, the SN, SN, S1, S2, S3, S4. You can go through, look through the values, see what it's looking like. You know, you can look find the convergence and divergence through multiple different tests. You don't always have to put the numbers. And then that's how you find the convergence divergence for multiple different scenarios. And then also how you can verify the conditions using other methods than just the test that you're going to learn. Um, thank you for watching. Have a good night.